Hello everyone, a very warm welcome to this video. In the previous video, we got introduced to Hive and Pig and the motivation. In this video, we are going to slightly dive deeper into Pig. So let's get started with Pig. So we'll talk about what exactly is Pig. Apache Pig is a platform for data analysis and processing on Hadoop. It actually offers you an alternative to write MapReduce code directly. Originally developed as a research project at Yahoo, the goals of Pig were flexibility, productivity, and maintainability. Pig is now an open source Apache project. How does Pig really work? Let's look at it. The main components of Pig are the data flow language, that's Pig Latin script. So you will express yourself in Pig programs. Once your Pig code is written, you would submit it or run it, and the Pig interpreter would pre-process and parse the Pig Latin. It will check for the data types. It will optimize it and kind of create a query plan, and finally generate the MapReduce job. The MapReduce job would then get submitted to job tracker or resource manager. And again, there would be a phase of map, shuffle and sort and reduce. That is how Pig works. The central idea of creating Pig was there were so many data analysts and business analysts who were not able to learn Java or who were not comfortable in learning Java, and they wanted an alternative to MapReduce to do this job. Also, it was never making sense that for doing a group by or a simple count, we should write 100 lines of MapReduce code if this could have been done by standard PLSQL. How do you get Pig? Now, as we've already seen that Pig is not part of core Hadoop ecosystem, or it's not part of core Hadoop. Core Hadoop consists of HDFS, MapReduce and Yarn. And just like app ecosystem, Pig is one of the ecosystem projects. So just like the way you install apps on your phone, you are free to install Pig in your cluster. Now for Pig, you don't really need additional setup on the cluster. All you need is the clients installing Pig. Okay, so that is how you get Pig. So what are the most important features of Pig? Pig is an alternative to write low-level MapReduce code. Many features enable sophisticated analysis and processing, like you can do HDFS data manipulation, you can run your Unix shell commands, you can do relational operations, positional references for fields, common mathematical functions, support for custom functions and data types, and complex data structures. Pig, along with the normal SQL-ish operations, also gives you a lot of other facilities, like you can manipulate HDFS, and you can write your own user-defined functions. So we've seen this. Now let's quickly look at some of the use cases of Pig. Where would you use Pig? Many organizations use Pig for data analysis, finding relevant records in a massive data set, querying multiple data sets, calculating values from input data. Pig is also frequently used for data processing, reorganizing an existing data set, joining data from multiple sources to produce a new data set. A few use cases. Weblog sessionization. Now you can take your log files, and let's just say that you have a use case that how many times a user visited in the last month. So Pig would be an ideal case where you load this data into Pig. So you say load log files as a certain bag, and then you would typically group by all the requests by a user and later by the URL or the format. So that way you exactly know that last month a user John Smith came certain times and what did he really do. One of the most common use case for Pig is analyzing your web logs. The second use case for Pig would be data sampling. Sampling can help you explore a portion of your Pig dataset. So let's just say you have 100 terabytes of data, and this 100 terabytes of data would want to be sampled into 50 megabytes. This could be done using Pig. So you can sample the data. There are ready-made functions available for that. You can use Pig for ETL processing. So you have data coming from multiple sources, and you might want to create a stream of or a sequence of ETL jobs, where let's say in first job you are validating the data, in second job you are fixing the errors, third case you are removing the duplicates, and then you are encoding the values. Finally, when everything is done, you are loading the data into a data warehouse. So that is one more use case for Pig. So let's quickly look at how do you interact with Pig? How do you basically write programs in Pig? Now, you can use Pig interactively. Yes, one way is you write the entire code of Pig in a file, but if you don't want to do it, Pig basically has a command line. So you just type Pig and you will be on a different shell called as grunt. So you can use Pig interactively via a grunt shell. Pig interprets each Pig Latin statement as you type it. Execution is delayed till you get a store or dump. So till you do a store or dump, you can continue typing your commands. Only then the execution happens. It's kind of lazy loading. So keeps on taking your instructions, and as soon as you do a dump or store, that's where the execution really starts. In this case, we are going to the grunt shell and we are first saying that all sales, load sales as name and price. Nothing really happens. Then you say big sales is equal to filter all sales by price greater than 100. Nothing happens. As soon as you click stores, bang, that's where the entire program would get loaded and run. You can also run or manipulate HDFS from Pig. So you can go to the grunt shell and you can run commands like create a directory and perform any operation that you would want to perform. You can also run shell commands or Unix shell commands in Pig. Those are certain additional facilities that Pig gives you. But the most common case that you would find is you would not be using Pig interactively via a shell. The most common use case is you would typically write a Pig script where you will have sequence of steps, and finally you will run the command as from the Unix prompt Pig and the file name, or from grunt you will run and the file name. Now the interesting part is MapReduce can actually run in HDFS mode and local mode. Very similarly, Pig can also run on local mode or HDFS mode. When you say you want to run Pig in local mode, that means Pig would actually act on local file system, not HDFS. And if you don't specify local, Pig would by default jump onto HDFS. So let's say when you say load this particular data, if you're running Pig in local mode, the data would be searched in local file system. If you're doing it in HDFS mode, the data would be searched in HDFS file system. As soon as you run your job and if it fails, you would basically have the logs created in your current directory. It would be on your local file system. So just to reiterate, both Pig and Hive literally require no setup from administrator because both of them are running on the client. Their entire focus is that they take queries from you in Hive or Pig and convert them to MapReduce, but the cluster still receives only MapReduce. So cluster is not aware of what is Hive and Pig, because cluster gets everything in terms of map reduce. So let's see what we've seen so far in this video. We've seen that Pig offers us an alternative to writing MapReduce code directly. Pig interprets Pig Latin code into MapReduce, and then you can run your code. You can find a lot of links about where you find more information from Pig. You can go to Apache main website. There are some more use cases of Pig. And that brings us to the end of this particular video.